So hey guys, welcome to Clear Interest Coding, and in this video we will be discussing the solution of June lunchtime increasing decreasing problem. This was a really great problem, and let's start. So here is the problem statement. You can read the problem, but if I explain the problem in simple and clear way without missing any important point, then the problem is something like this. So we would be given a sequence a1 a2 an, and we have to make some permutation of this sequence. That means arrange this sequence in any way of our choice such that there is an integer p from 1 to n. That means from 1 to this an there is some integer p such that the first pi, let me just explain. So suppose this is the given thing, this 1 2 3 4 5 and 6, n equal to 6. So such that there is one p such that there is an integer p such that first p element, that means these element are strictly increasing. That means these element values are increasing. So suppose this height represents the value of element. So for the first p element the height should be increasing. That means the value should be strictly increasing. It should not be something like equal also. It should be strictly increasing. And for the remaining element it should be strictly decreasing. So like if the height represents the value, then we can see that this is decreasing. So we have to make, from the given array we have to make this sort of an permutation. So and if we, this is the some sample input output, so if we are able to make it, we have to also print one of it, and if we were not able to print it, we have to just say no. So let's see this in sample example only. This would also make us really clear. So let's say that there is, if there is no duplicate present in the given input, like this, the 1 3 2 4, there is no duplicate, so the output can be simply the sorted version of it. Let's suppose there is no duplicates like 1 2 5 10. So if we see the height, basically in the height representation, 1 is here, 2 is here, 5 is something here, and 10 is something here. So this is strictly increasing always. So for element which does not have any repetition, we can just directly print them as they would be always strictly increasing. And now basically for those which are strictly increasing, we are clear that we can just directly print them and it would be strictly increasing only. For those which have them repetition, we have to come up with some conditions. So if we see, because there are some repetition, so suppose if we only represent it using some height diagram only, so suppose these two values are repeated, and so, and in the answer now let's see, suppose this was the maximum height. So if we see that what could be the possible arrangement here the height should be strictly less than it at each and every step. So if we see that these 2 points which have the same height, that means these two have the same value 10 and 10, suppose this is 20, these two cannot be placed here, because if we place these two here 10 and 10, this would be having same height, and what we want is, we want the height to be strictly increasing in this direction if we see. But if they both would have equal value, then this would not be increasing, and it is never possible. So the one observation here is, for values with same height, they cannot be placed on the same side of the maximum. So we can, the other option for us is to place this here, this 10 here. So the main observation here is, no two similar can be placed on the same side of the individual maximum. Okay, so for every array which does not have all element distinct, and we have to check that the count of repeating element is less than or equal to 2, because if it's less than 2, then we can just add it in any direction. If it is equal to 2, we have to add 1 in this side and 1 in the other side of the maximum. Okay, so now this is it, this is clear. And if we see, let's say the last example only we take, 1 2 3 3. In the height form, if we see, 1 is here, 2 is here, and 3 are here. So 3 3 2 and 1. So we have seen that this is already in the optimal way, that means here it is increasing. But since there is two duplicates of the maximum height, then we cannot place it in any other way. So what I am saying is, if there are two values, that is the maximum, are present, so the max element is present more than once, then also the answer is no. So once the answer was 2, if any element is present, any element is present greater than or equal to 2 times, greater than 2 times, strictly greater than 2 times, because if it is present 2 times, we can place it once in this side of the maximum and the other time in the other side. So any element is present greater than 2 times, or the maximum element is present more than one time, because there should be one overall maximum of this, that means the peak should be there. If there are two, then these two would have same value, which is also not possible. So these were all the cases which we need to check. So now let's get to the code for better clarity. So here is the code. Let's just get to the main part, and here it is. So basically what we are doing is, here we are handling the input part, and we are also sorting the array. So sorting the array would give us the array in increasing form, not strictly, it would be increasing, and then we are making this frequency array. That means we are counting that how many times this element is present, and if any element is present greater than 2 times, then we are marking it as not okay, and we will be printing here false. And also we are checking that the frequency of maximum element is, if it is greater than or equal to 2, then also the answer is 0. That means if it is greater than or equal to 2 is same as greater than 1, then also it is no. Otherwise what we are doing is, in the sorted array, so suppose this was the 1 4 4 9 20 12 12 12. So suppose this was the array. Now what we are doing is, we are maintaining two variable, high and low. So low is here, high is here, and the answer we are just allocating the memory of the same size as this, and we are going till while is less than low, and at each point this, and we are also maintaining an I variable which is at 0. Firstly we are doing is, while we are placing 1 here, and then I plus 1th element, that means I plus 1th element at high at here, so 3 would be coming here. So and then we are moving I to I plus 2. Now this 4 would enter here, and this 4 would go to the other side. So this is the main point which we were discussing here, that if there are two variables of same height, then we should put them in opposite side of the maximum. So by this, 1 will be coming in this side, other would be going in other side. Then I would be come here, then 9 will come here, and 12 will come here. Then the last, this 12 is, this is invalid because there are two with same value. Let's make it 13, because then it would be only checked here that the frequency of 12 would come out to be 2, and here it would be printing no. So if it is 13, then we would be taking 13 here. So this would be the final answer. If we see in the graph form, it is 1 here, 4 here, 9 here, 13 here, and 12 here. 12 would be greater than 9, and 4 here, and 3 here. So we are getting the desired structure. So this was the code, and I hope I was able to explain the problem clearly. If you still have any doubt, do let me know in the comment section, and like and subscribe to the channel, as I would be regularly posting competitive programming material from this contest also I have posted, and I will be posting from other contests. So thank you guys, thank you for watching.